Hello and welcome to the Bevy 0.8 to 0.9 migration guide. This is a reasonably large migration guide since Bevy had a reasonably large update, and unlike previous updates which tended to be more about adding new features, this one seems to have really gone hard on the changing how you currently use features. In a lot of the cases, this is actually a good thing because it's from the influx of new people using Bevy, a lot of the nuances have come to bear their head as not being apparent to new users. So they've kind of changed things that would catch people out because of being, not how you would expect them to be. So a lot of the changes are about making it clearer and impossible to do things wrong. So we start off with making the resource trait opt-in. It used to be auto-derived. Now you need to derive it yourself. This is just as simple as putting derive resource. And this is all about preventing you from using resources of crates that other people may have been using in their plugins. So like generic vectors of, like, say, uSizes, you can't use that anymore. You need to wrap it in a new type and call it a resource. So you can't use something that's not in your crate. Okay, they moved their plugins into having the own settings trait by reworking the plugins. This means that instead of having to insert like a window descriptor and then adding the default plugins, you now have to set the Windows plugin to have the Windows descriptor inside it. This is all to do with Bevy used to have a bunch of resources that you would initialize, and when the plugin was added, it would extract the resource, do its setup, and then never touch the resource again. This caused a lot of confusion in the fact that when you were inserting these resources, it gave people the false impression that the Windows descriptor could be changed at any time, whereas once the plugin was added, that was it. And if you didn't add it before the plugin, but instead after the plugin, it didn't care. It used the default values because it didn't know that you were going to add it. So now, when you add a specific plugin that has compile time settings, you must add those settings with the plugin. This has also been done with the asset server, moving the asset server settings, which actually could be changed at runtime, into the asset server. This means that things like watch for changes can't be set at runtime anymore and now need to be instantiated in like your debug build as opposed to something you could enable once the game was actually running. The add plugins with has been removed. This was a workaround system that could be added the ability to sort of take in a plugin group, and then you could then get access to the group that is constructed and do things like disable a specific plugin in that. Whereas now you simply use the builder pattern of saying the default plugins.build and then disabling and just passing the plugin like that. This also comes with a mandatory change to how the plugins work, the plugin groups work, I must say, which is more or less instead of returning a reference, like instead of returning nothing and getting a reference to the plugin group and building the plugin group yourself, you instead now take in a copy of yourself. So you consume yourself and return a plugin group builder. This allows for this pattern of calling build and then disabling things, because the builder chain lets you sort of stack those calls together. And then you're basically handing in the same thing. Whereas before it would construct the group, pass it to you and expect you to populate it. And that meant that you needed to edit it with a reference later. Using plugins setup resources is now only at startup, which is what I was just talking about. So things like log settings and that have been moved from being insert the setting to now insert with the plugin. Same with the image settings, where you used to be able to specify the resource. That was the default image thing, anti-aliasing, I think it was. Whether it picked the nearest or whether it did a square, the fucking rectilinear or whatever it's called, linear interpolation. And so now you specify that when you add the plugin as opposed to at startup, for the same reason of if you inserted it after you'd added the plugin, it wouldn't work. They moved the task pool options into the same thing where it's now part of the core plugins. It's an option as opposed to a resource that you could get access to. They've removed the watch from changes because, as we just said, the watch from changes was all about allowing you to at runtime change whether the asset server was doing that. So now you do it at startup. Spawn now takes a bundle. This is a huge change to how you interact with the API, mostly because it simplifies it down to, instead of having to know whether you've got a bundle or a component, all components are bundles, and you wrap them in a tuple to insert multiple at a time. This has a twofold impact of making it significantly faster because you don't need to guess at what archetype it's going to end at. So each time you insert a component, it chains them together, or it used to chain them together, which meant that it needed to add each one as an archetype and then to move it to a different one, to move it to a different one. Now it knows, at least if you do it properly, what all the components are, so it can move it to the correct archetype and initiate all the components. You can still call chained inserts, but this is less efficient than wrapping them in a tuple so that the compiler can know exactly what archetype it's going to end up as. So this also resulted in them removing the insert bundle things, because there's no point having insert, which takes a bundle, and insert bundle, which took a bundle. So all instances of insert bundle have just been replaced with insert. And the remove bundle intersection, which used to remove all the components that were in a bundle from a entity, now is been replaced with remove intersection, because again, specifically a bundle doesn't matter anymore. So they're saying about the constructor, as many operations as possible to improve ergonomics and cut down archetype moves. As I was just mentioning, the less moves, the faster it is. So instead of saying insert bundle insert, now you just wrap it in a tuple, or you can also just spawn it with all the things instead of spawning it empty and then inserting. Implemented bundle for components, like I was saying, all components are now bundles, which also means that you can get rid of this pesky bundle tag when you're making your own bundle, because it's assumed that they're all bundles. So even if you've only got a single component, it would still be a bundle, so the tag becomes redundant and unnecessary. They replaced the boolean on timers, whether it repeats or not, with a actual enum, time mode repeating or time mode once. This really has no impact on anything except it making it more readable on which true and false is because you passed in here like timer duration false, and now it is like timer duration once, which is much more readable to people that may not know how Bevy works, and you don't have to read documentation. You can just intuit the fact that once will only run once. They added global time scaling, which is basically a new feature that means that you can make all your time functions return a multiple value. So you can make everything run twice as fast that runs on delta time. So this also comes with renaming all the time functions that they used to have for time since startup has all been renamed to fit the thing of, they've renamed it to elapsed seconds, and it elapsed F32, as opposed to it was all over the place with time since startup as F32, so you'd actually convert the duration to F32, and seconds since startup was at F64, whereas when you used time.delta time, you would also, like delta time, which is the time between frames as opposed from startup, it used like this naming scheme of delta seconds, and delta seconds F32, so F64. So they've just made the time since startup API match with the actual Delta API. And they've also got raw functions if you want to access the unscaled time since startup. Okay, so change the UI coordinates from having the origin at the bottom to the top left corner. This is to be more in line with the rest of UI, but does require you to change your reflect directions. So like column reverse is now column, flex start is now flex end, flex reverse wrap is now flex wrap, and this goes on for all of them, just simply because it's sort of inverted. You also need to remember that cursor position is top left instead of bottom left. They renamed UI color to background color. This is just a simple rename, and I think it's just about making, again, more clear that the UI color is the background color, not a tint to the UI. Make the default background color for nodes transparent, which is very useful because a lot of the time you want to spawn a node and then put other things in it, but you want the node as a container. So now to get your old behavior, you have to make the background white again. And again, it's just more about being in line with other systems that people may have used in the past, so that Bevy is easier to get your head around when you're starting out. They clarified the Bevy UI nodes, fields, and documentation. All references to the old size name has been changed to instead use the calculated size. And I believe this is because the calculated size will be increased and decreased with scaling of the UI, as opposed to the size, which is fixed. They renamed size and UI. They removed size and usize generics. So originally, size and UI rect would take in a generic, which was then always value, because you could, in theory, do an F32, but this wasn't very good. And it's that, like it says here, if you're using a size F32, you may as well just use a vec2, because it's exactly the same thing, but with more functionality and more optimizations. So size is now only got value because it's specifically for UI and not a generic trait for other uses. They've removed margin and replaced it with a UI rect, which again, same kind of thing of like, they've removed some of the genericness. So now margins, which were always values, it's like, well, now they're exactly the same thing as a UI rect. So simplifying the API down nicely. They moved, and this is a really confusing, they moved size to Bevy UI. So they took it out of math and put it in Bevy UI. Then they moved rect to Bevy UI as well and renamed it to UI rect, which is all about removing that genericness. And then they moved the sprite rect into the Bevy math. So they moved one out of Bevy math and then put a different one in there. So that's going to cause some issues because you won't get a compile error, but the types will be different because I think their internal structure may be different. So they've also, now moving on to exclusive systems. You no longer need to declare exclusive systems. They are simply treated as regular systems, and Bevy will work out that they're exclusive by the fact that you're asking for mutable world access, and we'll take care of that all for you. And if you want to turn a normal system, a normal parallel system, a non-exclusive system, into an exclusive system, you call .@end, and I believe all end functions are run after the frame finishes and as if they were unique. So you won't have overlapping parallelization. Slow your game down, but you may require this for, say, forcing certain traits and actions to take effect without the risk of something else doing its thing first or after. Query state is exclusive systems can now be cached, which is that you used to have to instantiate your iterator for your query internally to the system, and this would then lose what it had done. So simply like things like changed wouldn't work properly because it had no way of knowing what your value was previously. Now instead you can give it a query state mutable reference and it will keep track of that so that the next time you run the system, it already cached. And it says that this is preferred because it is both easier to do and has better performance than the way it was done before. So Bevy has migrated their TextureAtlas from grid padding to just being from grid and taking 2 additional traits into the from grid, being the grid size and the padding as options. This means that you can now do the same functionality that you could do previously, except without needing the extra difficulty of knowing which one to do. And this also, I believe, allows for you to do grid or padding as opposed to the previous Bevy one, which was you had to do grid and padding. You couldn't just do padding, or they had multiple functions that was like padding, grid and padding. So Bevy has replaced its play with start and added a new play method, which won't overwrite an existing animation. This is to do with if you were playing an animation and you told it to play again after pausing it, it would start over. So now, if you want that functionality, you have to use start, which is mandatory from the beginning every time you call start, whereas play will just continue from wherever the animation was. And if you call play multiple times, it won't restart the animation, even if it's already running. They changed the gamepad.rs tuple into a normal struct. This basically means that originally it was a new type which wrapped around the ID of the controller, and that's all it really was the ID of the controller. And I think the button that was being pressed at a specific time. I don't remember what the trait was. But now you actually use the struct thing. So instead of calling .0, you call the appropriate field name. I guess this is for all the tuples. So gamepad used to just be a wrapper around it U64, I think, or U32. The button was a gamepad and a button. The axis was a gamepad and the axis. So all now you use the name as opposed to just .0 and .1. Add getters and setters for the input axes and button settings. This is about adding soundness to these systems. So you can no longer set the values to whatever you want, and they have checkers in place so that when you set a dead zone, it'll make sure that the upper bound is not lower than the lower bound and things like that, so that you know that your gamepad settings will always be valid. So, but you will need, if you were directly setting these values, to use these setters instead. Added a gamepad info exposing gamepad's names, which basically means they had to change the event type connected so that it can contain information, additional information about the gamepad. And so all these areas where you may need it have been replaced. And they also made the gamepad type copy, which means you no longer require to pass in references to the gamepad's API. Instead, you actually hand in the actual trait itself and it'll copy it. And this is mostly just because gamepad was just a reference, was just a wrapper around a U64, so there's no point passing that around as a reference when you could just pass the value itself. So all those APIs have been updated to take in gamepad and not gamepad reference. Bevy's updated all its dependencies to the most up-to-date, I would assume. And so this just basically means updating your APIs that were needing these. And the biggest one that they've mentioned here is that Bevy's WindowDescriptor, instead of having cursor locked, now has grab mode. This has to do with the fact that they added an additional mode. So instead of just having the cursor free and locked, there's also the contained, which means you can move the cursor around within the window, but you can't leave the window. Whereas locked is where the cursor can't move at all. Yep, and free is obviously the cursor can go anywhere on the screen. Support monitors selection for all window modes. Selection mode was moved to the centered into WindowDescriptor. So the monitor selection was moved out of window position centered and into the WindowDescriptor. So instead of being inside a separate thing, it is now its own separate section, and they moved the number to being index, which is really just a rename. So basically this type is now its own enum, and this type gets its own slot in the descriptor field, its own field in the descriptor, and that's all you really have to do is just basically expand that back out into two separate traits instead of, or two separate structs instead of one struct wrapping another. Window set position also takes in the monitor that you want to set the position on. And you can also pass in current, which will then dynamically select based on which one it is currently set to. Rename system chaining to system piping. This is just a simple API override. Again, I think it's about being more accessible to people coming from other applications, because chain and pipe would, it's just sort of arbitrary which one you would want to use, but piping is the more traditional name for it, because all your graphics libraries and all that use their pipelines, so it's all about one system leading into another. So instead of calling them chains, they're now called pipes. And it's just, again, just a simple rename of all their systems. The transform and its friends, as they say, have been changed from taking in an identity method to now having a const identity. If you don't know, transform identity is just transform with everything set to 0. So it's just like the default state, like no rotation, no scale, or a scale of 1 and a position of 0. And so now you just use the identity constant instead of the identity method. Renamed the transform mulvec3 to transform point and improved documentation. This is, I believe, to do with the fact that when you multiply a vector 3 by a vector 3, you are actually just telling it to point towards the other vector 3, like you point in this direction, as opposed to actually multiplying all the axes, because that's not really something that you can do with a vector 3, because how would you decide what axis gets multiplied by what? So Then they also changed the apply uniform scale factor to be a override thing that you can now multiply a transform scale by the scale factor instead of having a dedicated function for it. Operand, that's what it's called, an operand. Rename the face towards, they removed face towards entirely. So now if you want to do a map for face towards, you have to use mate for look at RH. I don't really know what that's short for, but again, just a simple find and replace. A lot of your code shouldn't really be relying on map fors anyway. They replaced the GATS trait with the actual GATS, so that's, again, just sort of the trait can be removed now, and now the Rust compiler has this functionality by default, and they no longer need to hack around it. They added methods of accessing the width of a table, but for some reason they've named them funny, because any use of table length should be replaced with entity count, and any use of entity count should now be replaced with entity capacity, or any use of capacity should be replaced with entity capacity. Yeah. This, again, is just a simple find and replace, so that should be fairly easy to deal with. They made handle T field ID private and replaced it with a getter. This is just, if you call the value handle.id, you can now just add the two parentheses at the end, so that basically you can't set it, is why this is done that way, and prevents you from trying to change a handle's ID when in reality you should be making a new handle, not changing an existing handle's ID. Added the time update strategy resource for manual time updating. They changed the value that They changed the value reported by time.delta on startup. Before, it would return 00 current time, which I believe is just, it would tell you the difference between the previous time and the current time. And now they've replaced it with 0, the approximate time between the time system and the present frame, which I believe is how much delay you can expect between when this frame reported the time being and when you actually get to read the time, which is more important for systems where you may be running at low frame rates, where the time that the frame rate reports may actually be even further behind when you actually get to executing your system, if there's a lot of expensive systems between then and you getting access. They added methods to silence system ambiguity, so instead of having to make an ambiguity set label, you can now just say .ambiguousWith, and the error will be silenced and no longer report the warning to you that you'll have ambiguous systems. They removed the unused depth calculation enum, so basically on all your cameras you had a depth calculation enum, you just can get rid of that, and shouldn't be too hard because that one's just tracked under error, select and delete, and all done. They made raw Windows handles fields in Windows and extracted window an option, so when you call this function, it'll now return an option, so you either tack unwrap on the end of that, or if let sum and unwrap it and do whatever. Obviously it was fallible, but they made it obviously panic in the handle as opposed to returning you the option to whether you were panicking or not. They removed inconsistency with child removal behavior. So if you were querying for changed children, this will no longer be the case if all the children were removed. Now the component itself will not be present. So you won't be able to detect the removal of all the children. You'll only be able to detect changes of partial removal of children, because if all the children are gone, it no longer has children. But in doing so, they've made it so that they can have the removed components children, which will tell you that all children have been removed. Entity ID has been renamed to entity index. This is, again, simple find and replace. They removed ExactSizeIterator from the QueryCombinationIterator. This, I believe, was done because even with a slight increase to the combinations that you're trying to compare, you can end up with greater than a umax size. So they're basically saying you can still get this functionality by calling sizehint.0, but be aware that if the size is greater than a usize max, then you will get a usize max. And you may be thinking usize max is a huge number, but if you combine like 3 sets of a few hundred different types of it, like a few hundred entities and you're comparing like combinations of 3 or 4 of those, you will very quickly get into very large numbers. So I'm assuming that's just about basically saying the size, even though we can calculate it, is not useful anymore because it's too easy to exceed that with combinations. The query filter type now takes a read-only world. It used to take a world query, now it'll only accept a read-only query. So this basically means if you were ever, I don't know why you would be using a reference to A and then a mutable reference to B as your filter, you should just replace that with B, because that will, one, let the system run parallel, and you didn't have access to the filters anyway. So you shouldn't have been doing this, but if you happen to be doing it, just replace it with and you will get the same functionality. They added a pop method to list trait, so this is to do with Bevy reflect. If you are reflecting list, you now need to implement a ability to pop the last value off the list. They removed an outdated workaround for impl trait, so the method scheduler getStage and getStageMute now accepts systems labels instead of a dynamic system label. So anyway, you've got passing in a reference to a system label, you can now actually pass in the system label itself because it just needs to impl system label and Bevy will take care of the rest. They added a change detection bypass and a manual control over change detection. So you've got to add the inner associated type and new methods to any type that you're implementing change detection for. And this is just about, in Bevy, you used to not be able to get access to a field mutably without triggering the change detection. Like, no matter, even if you weren't editing the value itself, if you were just, say, like giving the user the ability to edit the value but not actually changing it, the fact that you read the value mutably to give it to the user would trigger change detection. Now it's possible to implement systems so that the change detection doesn't trigger when you read it mutably. It only triggers if you then tell it. Even if you change it, it won't trigger when accessed this way. And you can then decide if you need to trigger change detection. This also allows for other systems to be placed in that may take in user changes. Like, so if some system from a plugin changes it, the plugin, outside the plugin changes it, the plugin can then internally tweak it without triggering change detection so that the tweak keeps getting run in an infinite loop. You can change it without tweaking it, say rounding it to 2 decimal places without triggering the change detection, because rounding to 2 decimal places, most systems don't need that to be considered a change. Ugh. Getting a bit long-winded there. Made internal struct ShaderData non-public. This is basically just if you were using ShaderData in your application, you were accessing the shader's data. That's no longer public. You shouldn't be doing that. So you'll have to create your own shader information, I guess. They made children constructor pub crate instead of public, which basically just means instead of calling children.with, they first renamed it from entities, and they made it private to Bevy, so only Bevy can construct children now. There's one issue I've noticed with this when I was trying to update the Bevy editor, please, like my branch of it to 0.9, is that it now has a bug because it can't reconstruct the children like it wants to, but I'm sure that'll have a workaround. I just don't know why it's doing it, so I just left it. But I'm not quite sure why they moved this from being public to private. I'm assuming it's so that they can be more sound with the hierarchy, because if you can go in there and change the children, then the hierarchy can become unsound because the user is changing something, whereas if only Bevy changes it, they can put soundness checks in to make sure that the children is always accurate. They renamed handle as weak to cast weak, and then they made it correctly cast the UUID to the type that you're casting, as opposed to before it wouldn't do that. Though it won't do this if it's a reference to asset path, obviously. They removed the sync bound from local. This is because they've removed the resource requirement. And because they've removed the resource requirement from local, sync is no longer required. Instead, it requires from world. And that's really it. Like, there's no big change. They say that there's a chance that you have existent points where it doesn't implement from world, and that in those cases, if it's not dead code, you should just wrap it in options so that it can be initialized as none. But that really should be a significantly rare case where you don't already have from world, because from world is implemented by default. Like if you've got default, from world is present. So almost every situation that you would be using a local resource, it would be very hard to initialize a local resource without it already having from world. They swapped out num compute crates for the threads available parallel, which is if you were losing the logistical cores and physical cores from the Bevy tasks crate, they've replaced that with the available parallelization, which is the logistical core, logical cores, and then they've removed the physical core count altogether. But if you need it, there's a crate that Bevy was just re-exporting anyway, so the num cores crate, and really they were just re-exporting that, so they've just taken that away, so you have to import that yourself. They've changed diagnostics from seconds to milliseconds, which simply means divide everything by 1,000. And you'll go back to being by seconds. So any system that uses diagnostics, you can now change that to being milliseconds, and it's more accurate. They added an exponential moving average into diagnostics, which is basically just they will average out the values over a course of time, so that you get much smoother results. It's anything recorded less than once every 1/10 of a second will have no change, because obviously it's averaging every 1/10 of a second. This is why I'm guessing that has no impact. And this wouldn't have an impact if you were sampling too small, because the average would just be whatever value was there. And then also you can turn off the smoothness by setting the factor to 0 if it's important for you not to smooth. And you can also still get access to the recent history if you need that rather than the smooth value. Nested spawn of scopes. Scopes now take in an additional lifetime parameter, allowing them to be nested, but does remove the ability to have non-send functions, non-send futures inside of a scope. But that's really all there is to that. Again, I'm assuming if you're using scopes, you would have much more understanding of what that means, but I've never really got into scopes yet. They've extracted resources into their own dedicated storage. So originally, Bevy had a archetype for unique components, and this was your resources, as in like components that only exist once, and they exist on an entity that you can't get access to because it is the world. Now it has its own storage. Though interestingly enough, they did say that all APIs getting this raw access that they're saying about how they've moved it have been removed, as these APIs allowed you to unsoundly get access, and instead you should use the world calls of get, insert, or remove the resource specifically. But if you need to get access to a resource, it's now in world.storage.resources as opposed to inside of the world with an archetype of unique resources _ reference to mute. Not quite sure what that was. I think it was just a pointer to the resources, what you'd get back. They cleaned up the fetch code, I believe because they've changed how resources are laid out. Fetching tables and fetching archetypes can now be returned with a single fetch code. That, or it's because GATs are now a thing, so they can dynamically decide which of these two to use, so you don't need to distinguish between them. Again, a simple like find and replace, because you can just replace all instances of fetch table and all instances of fetch archetype with just fetch. They've renamed the ElementState to ButtonState. And this is to do with the fact that the only thing that was using the ElementState was the button. So again, simplicity, like when it's much harder to work out what it's doing when you get reading the ElementState to get access to the button. They've fixed incorrect and unnecessary normal mapping code. So this is inside the Bevy PBR shader. It no longer maps the normal code. Not really into shaders, but I'm sure if you do shaders, this means a lot to you. I'm not quite sure, but they've changed that. This is a big important one because of the fact that I've been doing a scene series, is that the scene serialization format has been impacted. So the big changes are that the root of a scene is now a struct rather than a list. So instead of being a list of entities, it is now a struct that contains an entities list. This is so that in the future they can add, say, assets and dependencies into a scene, and they will be loaded as like separate lists inside the scene. Components are now a map of keys with their type as the key, rather than a list. This, again, makes perfect sense because each component can only have a single type, a single instance of each component, which means that you could, in theory, handcraft a scene that had 2 copies of a component and get unexpected results because one component will just simply override the other. Now it uses a map, and you'll get an error when you're decompiling, when you're loading your scene, that you've duplicated a component. And the type information is now omitted wherever possible, and this is to do with the new Bevy Reflect serialization system. We'll now intuit that once it's worked out what type you're serializing, it can then know the rest of the types inside that nested structure. So it obviously can't know the type of the component because components can have lots of different types, but once it knows the component's type, it doesn't need to contain any type information in turn after that for the rest of that component, because that can all be worked out by the compiler at compile time. So it's saying about you'll need to re-export your scenes if you're using 0.8, but it is possible to hand it as a scene. So as you can see in this scene here, they've got like entity and all this information. You can trim out the types and turn it into a map, and it will become significantly smaller and much easier to read. So like up there, it had entity 0 components. Now it has 0 and then a list of components, or a list that then contains components. And so then it has its components, and so once it says that it's a transform, it's got its translation, and it can intuit the type by knowing that a transform's translation is a vector 3, and it also knows that X, Y, and Z are F32s because the transform's X, Y, and Z. So it can infer the types based on knowing that it's a transform. It can then look up what the corresponding types are. Derive reflect plus from reflect for input types. This is to do with input types used to reflect their value, which means that you would return the actual struct and no longer had access to private fields because you would only get vector value, not a reflectable, interactable object like you did with other reflect. So this is now reflected properly. And if you were requiring the fact that you would get back an actual value rather than a reflectable object that you could interact with, you can wrap it in a in a wrapper and then reflect value on that wrapper, and it'll have the same effect as if you were doing what you were previously doing. They relax the bounds on an option T. This is to do with when you were using an option in your system, it needed to implement clone. Now it only needs to implement from reflect. And this is basically just to do with the fact that from reflect is more lightweight than clone and more generically usable. Most cases. And they're saying it also just doesn't really matter. You can implement clone, but it's not required anymore. They replaced reflect mute with a mute dynamic reflect. So they've really relaxed the requirement for sized on mute T. And so now you can take in a dynamic reference to a reflect and have that as mutable, which just brings the reflect crate more in line with the rest of Bevy in terms of convention on how you interact with things, using the mute pointer instead of a specific type. They removed the blanket serialized deserialization requirement for reflect on generic traits, generic types. This is to do with the fact that option T, vec T, and hashmap K and V used to require you to have serialize and deserialization on whatever types you were using on them, but Bevy reflect no longer guarantees that you have serialize and deserialize, and if you need that functionality, you need to specifically register. So in this example here, they're registering option string and then registering the data for serializing and deserializing an option string, as opposed to how Bevy used to do it, which was only if the options value, the T value, was serializable and deserializable would you be allowed to reflect it at all. Now you can register those after the fact, and making generics much more usable for non-serialization impact. They removed the plus equals, minus equals operators for the value and size traits. So instead you have try, subtract, and try, add methods that you perform on height and width specifically. So I'm assuming this is all to do with, again, these what these would do being sort of not particularly obvious, like a size plus an integer, would that increment both the height and the width? So they've changed that to now you have to try add and try subtract. This will also prevent overflow issues as well. And finally, they've changed it so that you have to pass in the glom vector types. You can't just pass in arrays of the vector. And so they're saying you have to now wrap that if you're using that inside of your vertex attribute. And this is about making all the vertex attributes optional. I believe when they've done that, they've now also said that you need to specify which vertex type it is, because Bevy can't intuit that by where you're placing it because they're optional now. That is a huge change log. Funnily enough, the migration guide took longer than the actual going over the updates of what they added. And as I was saying, it's because a lot of what they've done is go back and rework the APIs that Face uses to make it significantly easier for newcomers to get their head around what Bevy is doing and how to use Bevy. So hopefully you found this video useful. I will be breaking it up into chapters. Obviously, you'll know that by now because you're watching the video. That's each section. Do like, comment, subscribe, and my next video will either be on a cool new plugin that I just found for Bevy making menus, or the manually editing scenes, which for a lot of people may be useful for the migration. So I'll do a migration guide of editing scenes from 0.8 to 0.9, and then a different guide on how to create and edit scenes as you would to create a scene for your game. But that's all in next time. So again, like, comment, subscribe, and I'll see you then.